Hello students, I am Isha Mandirata. In today's video, I am going to discuss numericals of the chapter Fiber Optics. So let's start with the first numerical. So the refractive indices of core and cladding are 1.55 and 1.51 respectively. You have to calculate the numerical aperture of the optical fiber which is made from these materials. So I have been given the value of N1. N1 is given as 1.55, N2 is given as 1.51, and I have to find out numerical aperture of the fiber. We'll just write the formula of numerical aperture, that is under root of N1 square minus N2 square, where N1 is the refractive index of core and N2 is the refractive index of cladding. So I just substitute the values and I substitute it as 1.55 square minus 1.51 square. And this gives me the answer of Na as 0.3498. This has no unit because numerical aperture is the square root of difference of squares of refractive indices of core and cladding, and refractive index doesn't have a unit. So this is again a unitless quantity. And you know what is numerical aperture? It is known as the light accepting capacity of a fiber. So the answer we got is 0.3498. I hope this was clear. Now let's move on to the next numerical. So I'll just read the question first. A silica optical fiber has a core of refractive index 1.55 and a cladding of refractive index 1.47. You have to find out critical angle of core and cladding. You have to find out numerical aperture of the fiber, and you have to find out acceptance angle in air for the fiber. Now what do you mean by critical angle? Critical angle is that angle at which if the light ray is incident, you get the output as parallel to the two surfaces. So for total internal reflection, it is mandatory that the angle of incidence should be slightly more than the critical angle. So we are given the value of N1 as 1.55. We have been given N2 as 1.47. So let's first find out the value of phi c. Phi c is the critical angle. It is denoted as sine inverse of N2 by N1, where N2 is the refractive index of cladding and N1 is the refractive index of core. And you have sine inverse of 1.47 divided by 1.55, and this gives the answer of phi c at 21.51 degrees. Now next we have to find out numerical aperture. So numerical aperture Na, it is equal to, this is square of refractive index of core minus square of refractive index of cladding. So this is nothing but 1.55 square minus 1.47 square. So the value of Na we get is 0.4915. Now lastly, we have to find out the value of phi in max. What is phi in max? How do we find out phi in max? So phi in max, it is equal to sine inverse of under root N1 square minus N2 square. What is N1 square minus N2 square? I can simply write this equation as sine inverse of Na, and Na we already have 0.4915. So this gives me the answer of phi in max as 29.44 degrees. So this is how we calculated the three different values. We have calculated the value of numerical aperture, critical angle and acceptance angle. Now I'll just move on to one more numerical wherein I have a refractive index of core for step index fiber is 1.52. Diameter is given as 2.9 micrometers and it has a fractional refractive index of 0.0007. This is operated at a wavelength of 1.3 micrometers. You have to find the number of modes the fiber will support. Now, you are given refractive index of core. You are also given the diameter of this core as 2.9 micrometers. Then you have been given fractional refractive index. Now, what do you mean by fractional refractive index? Delta is equals to N1 minus N2 upon N1. The wavelength at which the light through the fiber will operate, that is also given. And you have to find how many number of modes this fiber will support. And we are given in the question that this fiber is a step index fiber, right? Now, how do we find out number of modes? So, to find out number of modes, that is Nm, that is equals to V square by 2. So, definitely we would need V. Now, what do you mean by V? It is known as V number, that is defined as 2 pi A by lambda into Na. I can simply write Na. What is Na? It is under root of N1 square minus N2 square. Now, just look at the question. You have been given the value of 2 into A, that is diameter. You have been also given the value of lambda. And from Na, I have only N1, but I don't have the value of N2. To find out the value of N2, we have been given the value of delta, that is equals to N1 minus N2 upon N1. So I can simply write N2 is equals to N1 minus delta N1. So N1 is given as 1.52 minus 0.0007, that is delta, into 1.52. Solving this, I get the value of N2 as 1.518. I will just substitute all the values, and instead of, I'll just write D instead of 2 into A, because I know A is the radius. So 2 times radius is the diameter. So I have pi, that is 3.14 into 2.9. Now just see, in the question I have micrometers and wavelength is also in micrometers. So I'm not writing the units. I'll simply write this as, so 10 raised to minus 6, 10 raised to minus 6 gets cancelled, into. Now I have N1 square is 1.52 square minus N2 square, that is 1.518 square. Do not approximate the values. So this will give us the value of V number approximately 1.21. Now we have already found out the value of V number. Now in the question it is step index fiber. So for a step index fiber, we can write number of modes Nm, that is equal to V square by 2. If it would have been graded index fiber, we would have written V square by 4. So now what do? I just write 1.21 square divided by 2. So I get Nm as approximately 0.738. So approximately 1 mode it can support. So this is how you solve this numerical. Now let's move on to the next one. So you have to calculate numerical aperture, acceptance angle of a fiber having N1 as 1.48 and N2 as 1.43. We have the value of N1 as 1.48. We have the value of N2 as 1.43. How do I find numerical aperture? A numerical aperture is equals to under root of N1 square minus N2 square. And that is equals to under root of 1.48 square minus 1.43 square. So numerical aperture is equals to 0.3814. This is the answer. Now we know the relation between acceptance angle and numerical aperture as phi in max is equals to sine inverse of Na. So we have sine inverse of, we have the value of Na, that is 0.3814. So I get the answer of phi in max as 22.4 degrees. This is the value of acceptance angle. What does that mean? This is the maximum angle at which the light should be incident in the fiber. If the light is not incident at this angle, it won't give us TIR. So this is the actual meaning of acceptance angle, that it would accept the light which is close to this, which is in between this angle. So this is the maximum angle, and that is the reason we also write phi in max. Now we move on to the next one. So next numerical says that you have an optical fiber core with refractive indices of core in cladding as 1.545 and 1.495 respectively. You have to find out critical angle, acceptance angle and numerical aperture. So we have seen the formulae in the earlier numericals also. So we'll directly just start solving with phi c, that is equals to sine inverse of n2 by n1, where I can write this as sine inverse of 1.495 divided by 1.545. So I get the value of 75.38 degrees. Now I'll just move on to numerical aperture. So numerical aperture is n1 square minus n2 square. So this can be written as under root of 1.545 square minus 1.495 square. So this numerical aperture is 0.3898. It's a unitless quantity. Now next we write phi in max. What is phi in max? It is the acceptance angle. So phi in max is equals to sine inverse of Na, that is equals to sine inverse of 0.3898. So we get the value of phi in max as 22.9 degrees. Next, we have a light ray enters from air to fiber. Refractive index of air is 1. Refractive index of core is given as 1.5. Refractive index of cladding is 1.48. You have to find critical angle, you have to find delta, that is fractional refractive index, you have to find acceptance angle and numerical aperture. So it's almost similar to the previous one. The only difference is that here we have to find out delta also. So let's start solving first with the help with phi c, that is sine inverse of n2 by n1. So this is sine inverse of 1.48 divided by 1.5. So phi c is equals to 80.63 degree. Next we have delta, that is equals to n1 minus n2 by n1. So this is 1.5 minus 1.48 by divided by 1.5. So this gives me the value of delta as 0.0133. Again, it's a unitless quantity. Then next we find out the value of Na. So Na is equals to under root of n1 square minus n2 square. So this is written as Na is equals to 1.5 square minus 1.48 square. So the value of Na we get is 0.2441. And lastly, we have phi in max, that is equals to sine inverse of Na. So that is equals to sine inverse of 0.2441. So this gives me the value of phi in max as 14.1 degree. Clear? So this was the numerical having only one additional parameter to be derived, that is delta. Now let's see what is the next one. So you have to find out the refractive indices of core and cladding of a fiber if numerical aperture and relative refractive index is given. Clear? So you are given Na, you are given the value of delta. How do you find out the value of N1 and N2? You have a direct relation between Na and fractional refractive index, and that is given as numerical aperture is equals to N1 under root of 2 delta. This is how you find out. So you are given Na also, you are given delta also. So just substitute the value and you can find out N1 directly. So from this I can say N1 is equals to Na upon under root of 2 delta. What is Na given? 0.22. What is the value of delta given? So I just write square root of 2 into 0.012. Solving this, I get N1 is equals to 1.420. Now we have obtained the value of N1. How do we find out N2? You have two options. Either you can use the equation of numerical aperture, that is Na is equals to under root of N1 square minus N2 square, because we have been given the value of Na and we found out N1. Secondly, you can use delta, that is n1 minus n2 by n1. So I'll be using this equation. Delta is equals to n1 minus n2 upon n1. So I can write n2 as n1 minus delta n1. I simply took n1 on the other side. This is 1.42 minus 0.012 into 1.42. So this gives me the answer of n2 as 1.402. This is one method. Second method, you can use NA. So you know that NA is equals to n1 square minus n2 square under root. Or you can write NA square is equals to n1 square minus n2 square. So this gives us n2 square is equals to n1 square minus NA square. So this is 1.42 square minus 0.22 square. Again, it will give you the same answer. You will be getting square. So then you have to do square root and you will be getting the answer as 1.402. So whichever method you feel is easy, whichever formula you remember, you can solve with any of them. So today we have seen different numericals, different methods from the chapter fiber optics. I hope you have understood all the numericals I discussed today very well. Thank you.